If you think about it, a rocket is just, like, everyone likes the flames and the chamber pressure and the high numbers and all that stuff, but really when it comes down to it, a rocket engine is 90% components. It's 90% how you get the fuel and oxidizer there. And our job is to make sure that we get it there safely and we get it there at the right pressures and the right temperatures.
I'm Brandon Taylor. I'm a technician operator.
My name is Aaron He. I'm a test engineer.
My name is Alex Rivera. I'm a Firefly test engineer here at Test Stand 3.
This is Test Stand 3. It is the component stand for the company. It's not necessarily one test stand. TS3 is more so a complex of smaller test stands that fit the needs for all the componentry within the company. We test all the componentry for Alpha, Eclipse, Blue Ghost, and Electra. Most dominantly, we test the Alpha componentry, but it doesn't necessarily negate that we do other things. We test all of the pressure vessels within the boombox and HBCS, all of the actual componentry, the valves, we test on main pad and very soon on beta stand. Predominantly what we're doing, we don't make fire, more so what we're doing is cryogenic testing to ensure the components are going to hold up under cryogenic conditions while they're pressurized. You don't necessarily have the same results whenever you test things at ambient versus cryogenic. So this is the unsung hero where we get everything cold and make a bunch of clouds.
So right now on the stand back behind me is a stage 2 vent valve for the stage 2 aux tank.
Every tank has their own particular vent valve. Effectively, it's a relief valve for a large vessel, but it has the means to be able to close when commanded. So we're able to pressurize the tank beyond the point of which that valve will self-relieve. And the reason that we're testing it out here is due to the fact that we are able to chill the valve down to cryogenic temperatures, very similar to what the vehicle would see, and then confirm that the valve itself will perform correctly outside of an ambient scenario.
When you're testing, a TS3 is really quick pace, right? And so having a good knowledge base of each valve going in is really important because sometimes during the test, a valve will act a certain way that you either don't want to or you want it to, and then you have to shape your approach for the rest of the test to that valve based on how it's acting, and that's completely dependent on, like, hey, if you look at this problem, this is what this valve is doing. Like, just based off of the pressure downstream or the temperature, this is what the valve is. It's maybe stuck, or it's maybe flowing wrong, or it's leaking or something like that. You need intimate knowledge of each article to make those snap decisions during testing.
Right now, we are just outside of TS3. We're currently near the boombox, which is the test stand that I primarily operate on. It is where we test most of our COPVs and also any articles that we expect to experience high pressures. So we put them in here, we install them, and we essentially take them to a pressure limit that they can't withstand.
So, like, when I'm properly chilling in, this is what's going on.
COPV stands for carbon overwrap pressure vessel. Our COPVs typically go in the rocket and they handle all the pressures that go throughout the rocket, whether it be into the tanks, into any RCS, or also helium throughout our valves as well, or any purges. The COPVs are the highest pressure rated article on the rocket. Therefore, when it comes to our test stand and being able to test are there limits, we need to make sure that our test stands are capable of withstanding those limits as well. Behind me, we have our Eclipse medium launch vehicle COPVs. These are much bigger and much heavier than we would see for our Alpha COPVs. They also hold a lot more volume, which makes sense given the much different size of the rocket that we're going to be dealing with. However, they are kind of based off of the COPV heritage that we've developed for the Alpha bottles. Therefore, a lot of the pressures that we work with, but also the winding techniques are still somewhat similar. The benefit of building and testing the COPVs in-house is we get a full idea of how they are designed and also how they operate at the component level, but also at the rocket level. So we can get an idea of how their properties will change throughout the different life cycles that we'll experience when it's put on the rocket.
Yeah, I mean, it's been really, like, hands-on, so it's not a traditional mentorship where, you know, one person is like, it's almost like in stages where one person teaches you and then you go out and do the thing. It's like here, it's more like the old guard, I guess I can call them, teach you while you're both doing the thing. And so it's very much like, hey, both of you go out there and, you know, set something up on the stand. The people who have been here for longer can tell you while they're doing it, and then you can take part in it. And so it's like a very active form of mentorship.
Try pressing it the other direction and see if it seals.
Yeah.
I value the ability to train new people and see them grow within their own roles. Within the industry, sometimes it's fairly easy to put your blinders up. You get very fixated on only what you're working on, and you don't understand how your piece affects the big picture. Being able to move around within the company as well as within the industry, I've got to see a lot of different ways of doing the same thing. There's a couple different ways of skinning a cat effectively. So within that aspect, like whenever I teach, I like to explain significantly more information than what you're actually needing at that point in time, so that you have a broader aspect and understanding of like how this affects everything.
I definitely have some test engineers that kind of took me under their wing from when I started and still help me out to this day. Something I try to learn every day is how do things affect the stage level, and so I constantly ask the stage test engineers to figure out, hey, how does this affect something when it's put on the stage? How does it different from when it's on the stage? Or even technicians figuring out the proper way to set something correctly, whether it's torque spec'ing or whatever it may be. At the end of the day, I feel like this is all one big melting pot of ideas and knowledge, and it's just so much to absorb. And I think coming in day to day, I feel like I learn something new every single day.
What makes me proud? I think I have a little bit of ownership in the ability for Firefly to send things into space, right? And you can point at each component and be like, hey, this one works because I know it works. And that's like, and then it goes into space, and that's like awesome. Because it's like, wow, I can point at something on there and say definitively, like, hey, from the design, I made sure that that was good.